Hello everyone, we are going to start with determinants. In determinants, we are going to cover the following. We're going to find the determinants by a cofactor expansion, apply properties of determinants to compute them, determinants of a matrix, then use Cramer's rule to find solution of a linear system, and use adjoint of a matrix and determinants to find the inverse of a matrix. So let's first start with what is a determinant. Now, determinant is a function that associates a real number with the square matrix, say A. We denote it by determinant, so DET, and then we have this matrix in parentheses, or we have a matrix in two vertical lines. Now, if you remember, we have already done finding a determinant of a 2 by 2 matrix, which is basically you are multiplying the two diagonals and taking the difference. And by convention, we start from the top left and go to the bottom and then subtract the top right going to the bottom. So determinant of a 2 by 2 matrix is A11, A22 minus A12, A21. Very important fact that determinant of a matrix is a number. It's very easy when we have a 2 by 2 matrix. But what happens if we have a matrix of size 3 or above? So for that, we're going to learn some concepts before we learn how to find that determinant. So the first concept we're going to learn is a minor. What's a minor? If A is a square matrix, then the minor of entry Aij. In other words, if you remember, if A is a square matrix, we can write a square matrix as Aij 1. Now, as it's a square matrix, the rows and the columns are going to be of the same size. Suppose it is n. Okay, so when I say is a square matrix, the minor of entry, so each entry I'm talking about like 2, 0, 3, each one of them is denoted by capital Mij. It is given by the determinant of a submatrix which remains after the ith row and the jth column. That means this Ij. So let's start with an example to explain it. Consider this matrix. The first row is 2, 0, 3, second is -1, 4, -2, the third row is 1, -3, and 5. I want to find the matrix M11. So what I'm going to do is, for M11, just so that I don't mess up this one, I'm just going to show you over here. So if I have 2, 0, 3, -1, 4, -2, 1, -3, and 5. So what we're going to do is we are going, M11 means the first row and the first column. Let me show you again here. We cancel out the first row and the first column. That's what we're looking for, M11. What is left? You just find out the determinant of this 2 by 2 matrix. So it's 4, -2, -3, and 5. So what is the determinant? Remember for this one, it's 20 minus 6, which is 14. Now let's look at M12. Now for M12, I'm going to use another color so that we can see it. So M12 means first row and second column. Okay, I'm going to use the blue marker. So it means first row is cancelled and the second column is cancelled. So what are we left with? -1, 1. Remember, we're finding the determinants. Okay, so we are left with -1, 1. Remember, first row, second column. Keep this in mind. So whatever is left, just pick them up and the order with which is written in the original matrix, that's how we go. So -1, 1 is the first column. We kept that as the first column. -2, 5 is the next column, which is remaining after we remove the first row and the second column. What are we getting here? We are getting -5 plus 2. So it is -3. Let's look at M13. Now in M13, it's the first row and the third column. Okay, I'm going to use the green marker, guys, here. So it's the first row. I'm looking at M13. So I'm trying to be as consistent as I can with the colors and the minors we're looking. So the first row and the third column. What are we left with? We're going to find the determinant of -1, 1 and 4 minus 3. So what do we see here? So it's 3 minus 4 minus 1. Let's go ahead and look at M21. Now for M21, guys, remember this is not the second row, the first column. Okay, so second row, I'm just trying to avoiding coloring. So just follow my this pen, which is, you see this little bubble which is falling, just follow that one here. So I'm looking at M21. I'm going to use my red color for this one, M21. So I'm saying second row. So that means this row. You see this little circle moving around. So you basically cancel this second row and the first column. So what are we left with? We're left with 0, 3, the first row, minus 3 and 5. So you're going to find the determinant of that. So it's going to be 0, 3, minus 3, and 5. So what's the determinant? It is 0 plus 9, because minus of minus 9 is a plus 9, this is 9. Now let's look at M22. I'm out of colors, guys. So hold on, let me see if I can get more. Oh yeah, let's look at, say, a little gold. Hope it works. Okay, so kind of a little gold here. So second row, second column. So second row, second column. What are we going to get? Okay, so we're going to get 2, 1, 3, and 5. So what do we see here? We are having 10 minus 3, a 7. Okay, what's M23? Let's look at darker colors here. Let's go for a very dark orange. Yeah, let's go for a darker orange. Okay, so M23, second row, cancel the second row, third column. So what is the determinant we're having? Second row, third. So 2 and 1 and 0 minus 3. What are we left with? It's a minus 6. Okay, let's look at M31. Now it's the third row, guys, and the first column. Okay, I'm going to go back to my red, guys, here. So this one, third row, first column, 0, 3, 4 minus 2, we're going to get is a minus 12. Okay, what is M32? Third row, second column. So it's going to be 2 minus 1 and 3 and minus 2. So what are we going to get here? Minus 4 plus 3 minus 1. Now M33, guys. Third row, third column. Third row, third column. You're getting 2 minus 1, a 0, and a 4. So what you're going to get is an 8. Okay, so now I would like you to get your own pen and paper and work on this problem following the guidelines I just did as an example for you. I would like you guys to find the minus of the matrix given below. I've written down the answers for you, but I would like you to practice on your own. Literally, I will be giving you, so when you're given this one, select M11, first row, first column. You're getting would be a minus 2. I would like you to write it down. So I'm just going to write one for you here. So this is basically the matrix the determinant of a matrix 0, 1, 2, 1. So go ahead, write down each one of them and see if they match the answers. If there are issues, just send me an email. Okay, guys. Now we're going to look at the next concept, which is called cofactors. Now, this number, minus 1i plus j, times the minor of the ijth element, is called the cofactor of the entry. It's aij, guys. Yeah, a little typo. So it's not amij, it's aij. It is denoted by capital C, ij, or Cij. Doesn't matter what you want to write. Now, this is very simple because it's basically you are multiplying the minor of every entry by a minus 1, adding the minus 1 to the power your number of rows plus the number of columns. So M11 is basically going to be the same as, C11 is the same as M11, which is 14, because minus 1 squared is positive, so it's 14. Let's look at C12. C12 is what? Minus 1 to the power 1 plus 2, and M12 from previous slide. This is minus. Now what is M12? M12 is a minus 3. You can go back and look. So the final answer for C12 is a 3. Let's look at C13. C13 is minus 1, 1 plus 3 times M13. So this is positive, guys. So minus 1 to the power 4. So it's simply minus 1 as what is M13. So similarly, you can do C21. I'm just going to write this one as minus 1, 2 plus 1. That is a negative. M21. Now minus this is going to be a minus. Now what is our M21? If you remember, is simply 9. So the answer is a negative 9. Now C22. That is simply minus 1, 2 plus to the power 2 plus 2, M22, it's a positive. So simply C22 is the same as M22, which is a 7. Now C23, minus 1 to the power 2 plus 3, M23. Now remember, this is going to be a negative. What is M23? M23, guys, is a negative 6. So C23 is a positive 6. So following the same manner, your C31, guys, is going to be minus 12, because 3 plus 1 is this 4, minus 1 to the 4 is a positive number, so C31 is the same as M31. Whereas C32, you will have a minus, guys, in the front. And what is M32? So what is M32 is a minus 1, so minus of a minus 1 is a 1. So C33 is the same as M33, the answer is an 8. Okay, so we have got all of this. As I told you the previous one, for minors, I would like you to practice finding the cofactors for this matrix, which was already given. So if you had done the work for the practicing the minors for each one of these entries, you just had to change. So I've just written down the number for one of them for you. I'll go ahead and fill up the rest of them. So let's look at some observations for the cofactors and the minors. First of all, the cofactor and a minor of a matrix entry of an entry aij, it just differs by a sign. And a quick way to find the cofactors is by doing this checkerboard array as shown below. You have plus, minus, plus, minus. If you go row wise, or if you go column wise, plus, minus, plus, minus. So in other words, you see the signs are alternating as you go either row or column. Okay, now comes how can we use these cofactors to find the determinants. We're going to find the determinants by a cofactor expansion. What basically it means is that you can go either row or a column to do it. So let's read the theorem. It says the determinant of an n cross n matrix is the sum of the products of the elements of any row or any column and their corresponding cofactors. For example, if I want to expand across the ith row, That means the determinant of this A is AI1, CI1 plus AI2, CI2 dot 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 plus AIN, CIN. Now this is very important. The subscripts of the element value of that entry is the same as the cofactor for that. It's very, very important. Similarly, if I'm going across the jth column, it will be A1j, C1j. Remember, this is always going to be the same. Plus A2j, C2j, plus dot dot dot, plus ANJ, CNJ. So let's go ahead and apply this to the example we have been covering so far. Now consider again the same matrix. I want to expand by row 1. Okay, okay, so I need to give this a little, so row 1, let me just write, this is what I mean by row 1, make my life simple. So this one is, remember, row 1 means first, I is 1, A11, C11, A12, C12, plus A13, C13. Now what's A11? A11 is 2. Now what is C11? If you go back, your C11 was 14. A120. So what is C12? Even if you write it, no, it's not a big, so it's C1, it's 3. A13 is a 3. And C13, remember, is minus 1. So what do we get? 28 minus 3, 25. Okay, let's see what happens if I do it by column 3, expansion by column 3. So A13 is 2 times C13, C13 is minus 1, plus A23 is minus 2, and C23, if you remember, is 6. Then A33, remember A33 is here 1, sorry, we are doing by column 3, yeah, 3 minus 2, 5, it's 5. And C33 was 8. So if you do this is what? 9 minus 2 minus 12 plus 40. The answer is 25. Notice the beauty of determinants. It does not matter where I'm doing my cofactor expansion. I can do by any row or any column. My answer will always be the same. Now if I start getting different answers, that means something is wrong. That's one of the biggest clues when we're doing determinants by cofactor expansion. Okay, so guys, I would like you to work on the same problem we have been doing so far. Now, you can pick up any row or column to find the determinant. The answer is minus 6. So go ahead and do that and see if you're getting minus 6. If you're not, that means something is wrong. Let's look one more theorem over here. If you have a triangular matrix, then the determinant of A is the product of the entries on the main diagonal of A. So it's wonderful, guys. Because then we don't have to worry about applying, even if you apply the cofactor expansion, you will automatically see it will still be doing the same thing. So I'll do both of them for you. But according to this theorem, the determinant is nothing but the cofactor expansion, is the product of the entries. So according to this theorem, the determinant of A is what? 2 times 4 times 9. It's a 72. So what we can do is, let's check by expansion, do we get that too? So I'm going to do by row 1. Expansion, I'm going to do by row 1. So that means I just simply have to multiply 2, and it is, remember, it's a cofactor. So 2C11 plus 0 times C12 plus 0 times C13. So I don't even have to worry about this. So 2C11. What is C11? Minus 1. Remember, you have to do minus 1, 1 plus 1, and M11. So what is this? This is 2 times, what is M11? It is the determinant of, you remove the first row, first column, you get 4, 0, 0, 9. And when you find the determinant of this 2 by 2 is what? It's same as 2 times 4 times 9 is 72. So if you see a triangular matrix, now remember this is a lower triangular matrix because you have zeros on the top. So what we have? Perfect. We are having, the same answer as we would have done by cofactor expansions. So it's nice to know and remember these theorems. Okay, let's do one example where we have a bigger size matrix. We're going to find the determinant of this 4 by 4. One of the key points is, guys, that when you're doing these kind of determinants, look for the row or the column which has the maximum number of zeros. So if I notice here, we are actually having this column 3. Notice this column 3. This has the most number of zeros. So what are we going to do? We are going to go ahead and do cofactor expansion by column 3. That's what we're doing. So we have A13, C13 plus A23, C23 plus A33, C33. Oh, no, two doubles plus A43, C43. So all these are zeros, so only this is the one which is important for us. So it is 3 times, now C33. Remember, I forgot to write it's -1 times 3 plus 3. So basically, it's a simple 3 only. It's just the value here. And then we write down all the terms. We remember we're going to cancel this third row and the third column. So we will have 2, 0, 0, 1, -1, 1, 4, 2, -3. And then there we go. This is a bunch of zeros. So we just apply expansion by C1. So 3 times 2, remember C, this is what? -1, 1 plus 1. Keep that in mind. What are we left with? -1, 2, 1, -3. Answer is a 6. Pretty easy. So I would like you to guys practice these questions from the book. In section 3-1, 1 to 4, 9, 11, 25 to 30. Thank you.